All right, this is the Math Models Unit 2 Lesson 2 video. This lesson can be summarized as basically the Pythagorean theorem. So that's what this entire lesson is hinging on, is you understanding the Pythagorean theorem. So first things first, we need to get some terminology out of the way. When we look at a right triangle, and a right triangle is any triangle that has a right angle in it, we think of the three sides in the following way. We have two legs. The legs are the things that make up the L shape of that right angle. So leg A and leg B, leg A, leg B. It doesn't matter which one's A and which one's B, just that they are each a leg. And then the longest side, the one that's sort of diagonal and across from the right angle, is called the hypotenuse, and it's referred to as C. So we have these three sides, A, B, and C. A and B are legs. C is called the hypotenuse. The hypotenuse is the longest side. So what the Pythagorean theorem is a property of right triangles that says that if I square the A and the B, in other words, multiply them times themselves, add those two answers together, it equals the same as if I took the C and squared it. Okay, so I'll do one example of kind of how this looks. So when we talk about this, we look at a right triangle. Call this A, we'll call this B, we'll call this C. So as an example, if I have this right triangle right here, and I say that A equals 3 and B equals 4, then how would I find what C equals? And this is exactly what you're going to be doing when you do these problems. So again, our Pythagorean theorem formula is A squared plus B squared equals C squared. And you're going to take each value for the ones you know, and you're going to put them in for A and B or C, depending on what you know. Since we know A is 3, we're going to substitute that for A. A squared becomes 3 squared. B is 4, so that becomes 4 squared. And then C squared is the thing that we're looking for. Then we're going to simplify what we can, and then we'll kind of talk about what the last step is. So 3 squared is 9. 4 squared is 16. You can use a calculator for that if you want. Otherwise, hopefully in terms of multiplication, you know 3 times 3 and 4 times 4. If not, calculator using your calculator is totally fine. So then 9 plus 16 equals C squared. 9 and 16 added up becomes 25 equals C squared. Now, a lot of people make the mistake of thinking they're done when they get to this step, but that's not actually what we're looking for. We actually want to know what C equals. And so in order to do that, we have to do the kind of last step of any Pythagorean theorem problem is to take the square root of both sides of the equation. Square root and squared are inverses of each other. And when we say something is an inverse of each other, it means that they cancel each other out. So that means the square root and the squared get canceled, leaving me with C. And then the square root of 25 is 5. And so that would be the answer for the C value of this problem right here. All right, let's do another example. All right. So I have another triangle. Oops. We have another triangle. And we'll say we have A value of 5, a B value of 12, and we want to know what C is equal. We'll do another one of these C ones. All right, so go down to our formula. Our formula is A squared plus B squared equals C squared. A is 5, so it becomes 5 squared. B is 12, so that becomes 12 squared. And we want to find C squared. Again, I'm just plugging in these values. Then we work it out. 5 squared, 5 times 5 is 25. Again, use your calculator if you need to. 12 times 12 is 144. Then we add those together. 25 plus 144 is 169 equals c squared. And then, of course, our last step every time is to take the square root of both sides of the equation. That cancels out, leaving me with c equals the square root of 169. Let's jump over here and find out what the square root of 169 is, and it's 13. C equals 13. So that's pretty much what you're doing anytime you're looking for the hypotenuse. So notice in both of these examples, C was the thing that we didn't know. So let's do a couple where we don't know what C is, or sorry, when we know what C is, but we don't know one of the other values. So let's just jump over here. So if we don't know one of the other values, we're going to have a slightly different situation. So let's say we have A equals 6, B equals, we don't know, and C equals 10. So we'll come down here and we'll get our formula out. A squared plus B squared equals C squared. A is 6, so 6 squared. B is unknown, so we're going to leave it as B squared. And C is 10. 10 squared. 6 squared is 36 plus B squared equals 100, which is 10 times 10, or 10 squared. So now we have this equation, and we still want to find out what B equals. So in order to do that, we need to get B by itself, kind of like C was in the other types of problems that we've been doing. So we're actually going to move the 36 across using algebra. Hopefully that doesn't look too weird to you. And we're going to be left with B squared equals 100 minus 36, which is 64. And then we've already discussed this multiple times at the last step. Take the square root, cancel, cancel. B equals, and in this case, the answer is 8. So what you've seen is that when you're looking for C, you just add the A squared and B squared and take the square root. When you're looking for B or A, you subtract the B or A from the 100 or from the C, and then you solve for the missing one. Let's look at another example. And I'm going to do an example where this does not work out to a nice whole number. Works out to something else. So let's say A is the unknown this time. B is equal to 8. And C is equal to 14. So again, same deal. A squared plus B squared equals C squared. We don't know what A is, so A is going to say A. B becomes 8 squared, and C is 14, so 14 squared, 8 and 14. So we begin working this out. A squared plus 64 equals, I actually don't know, 14 squared is 196. So we're going to subtract, let's get a different color here. We're going to subtract 64 so that we can get A by itself. That goes away. A squared equals 196 minus 64. Let's hop over to our calculator and do 196 minus 64. Oops. Let's clear that out. Clear. 196 minus 64. Keep messing that up. There's a 9. Now we get it. 132. So we're going to take the square root of both sides. Square root of A squared, square root of 132. This cancels, leaving me with A equals, and then the square root of 132. Go try that over here. Square root of 132 doesn't equal a whole number. It's 11.49. And so that's what I'll put. 11.49 is the approximate answer. So you can see it's okay if it doesn't work out evenly. You're still going to put your answer like that. And these examples are going to be all the examples that you're going to be seeing in the lesson. So I'll just kind of run us through a few of these. Number 1, we're looking for C. We're given A and B. Number 2, we're looking for C again. Number 3, looking for C. 4, okay, number 5, now I'm looking for A. So you'll subtract. Number 6, looking for B. Number 7, looking for A. And then we have a few word problems. I'm going to get you started on these by drawing some diagrams to get you started. Jalen is flying a kite on the end of a 35-foot string. The wind catches the kite and carries it to the top of a tree 15 feet away. How tall is the tree? So we have a tree. We have the kite. We have the string. And then we have the distance here. So it says here that the tree is 15 feet away. And the string is 35 feet. So you should be able to tell pretty quickly that this is my C, this is my B, and the unknown is my A. And so all this is a Pythagorean theorem problem disguised as a word problem. And so now you can solve for A using the methods we talked about. Next one. An equilateral triangle has side lengths of 6 feet. So an equilateral triangle means it looks like this. 6, 6, and 6. Find the altitude of the triangle, splitting the equilateral triangle in half. So it's like this. Right? So if it splits that in half, let's go ahead and get rid of this and get rid of this whole other side of this. And let's decide how long we think everything is now. This is still going to be 6, and this is going to be 3 because it's been split in half. Not only that, we now have a right angle. And then they want us to solve for this side right here. Well, we already know that B is 3. We know that 6 is C, and so then we're solving for A. Again, just producing a right triangle to use to solve using the Pythagorean theorem. Always just remember the legs are the things that make the L, and the C is the thing that is the longest side. All right, road salt is stored in a cone-shaped building. Sorry, I keep drawing on here. The base of the cone has a diameter of 26 feet, 26, and a height of 14. Splitting the cone lengthwise will create a triangle. That's right here. So in other words, we're getting rid of half of this 26. So if we get rid of half the 26, then we're looking at 13, and we're looking at a right triangle. And so then it looks like we're trying to figure out the length of C. So I'll let you finish that one out using the Pythagorean theorem. And that's it for this lesson.